From the 28,103 to total from 99,001.
28,103, right? Say that again?
Yes, from the 99,003 to the 6,000.
Exactly, all those. The EV, the dryer, and the range, that's it. We don't change anything on that. We just 100% those. Plus added to the general lighting, small appliance, and laundry service.
For the 7.5K VA, how do we put that to
I multiplied only 7K.
No problem. It'll be at 1,000. That the K means 1,000, so it'll be 7,500.
5-1.
And so 7
For the
is
area,
7,000.
it has its own section
We have them both.
on papers.
And I could have done, I did, and I just forgot to do it, 4.5K VA as well. Usually for a dryer, you get the whole VA, but sometimes with the oven and especially with units that have motors like air conditioners, you get they tell you reduce the KVA.
Because
7,500 times 0.8.
it's 6,000.
Yeah, range, and I'll point those out too here. This range, this is, well, I'll put the whole article, 220, oops, sorry, 55. And then the air conditioner, 100%. There was another question on, no, I think we're good there. That was 2055 too.
Hey, Mr. Perez,
Yes,
for appliances, if they're above 500 watts, like 4 of them, you apply the 75% to all of the appliances, right?
correct. You come up with a total and then you do that.
Okay.
However, in this case, we're not gonna do it. All right, we're already there, so I was just waiting to see what answer I got. But this is our only appliance other than. Air conditioner falls under its own category. Range falls under its own category. Dryer, and those are appliances. EV is not an appliance. All right, so if we're good. All right. So I'll just slide over the 2800, put it so that we can keep going down below. All right, this is our total so far. I don't think I'll ask a question that big to throw in range, and because by that point we're just almost done. Yeah, range on its own, HVAC systems, heating or cooling on their own. Go ahead.
There's only 3 of them, you add them all, and it's at 100%.
Exactly, just at 100%.
And even if we had a 4th one, it still doesn't get the 500 watts. So
Because of that garbage disposal being so small, correct, also.
those are at 100%.
Yes.
Range 650, 4,800.
Now, if we had a 5th one and that 5th one was over 500, then we ignore the garbage disposal and then we do the 75 for everybody.
What article is the air conditioner?
The air conditioning article, let's see here, right below it, and we, non-coincidental loads, yeah, I'll write it right here, 22060. Also on the same page, right below, everything is 96 gives us the whole. Non-coincident, if it is unlikely that 2 or more non-coincident. So I didn't ask it this way, which would be a question for exam 2. If I had a heating system that was 7,500 VA and I had an air conditioning system of 4,500 VA, what is my total load for heating and cooling? I guess that's a way to ask that.
AC was at what?
AC is at 7,000.
You would use the 7,000 one?
Yes, so because I'm not giving you a heating system, sorry, the heating was 7,500 and the HVAC was 4,500. Just to make 2 difference, right? So what this is saying is if you have that system, where most people do, most people have heating and cooling, although my friends in Florida, Miami do not, they don't have heaters in the house, some of them. Non-coincidental loads that will be in use simultaneously. So heating and cooling is one of those examples that won't be on at the same time. Using only the largest of those 2 that will be used at one time for calculating the total load of a feeder or service shall be permitted. The bottom here is if a motor or air conditioning load is part of the non-coincidental load and is not the largest of the non-coincidental loads, then 125% of either the motor or the air conditioner load, whichever is larger, shall be calculated. And what they're saying there, what the rest of this is saying is, it gets a little bit more detailed, but if I have an AC system that's, let me try to choose a number that could potentially get there. 6,500. All right, and I had the heating system, and the heating system was 7,000. Right? But because, as it says here, if a motor or air conditioning load is part of this non-coincidental load, so in this case they are, I have to take this 7,500 now and multiply it by 125%, see what this number ends up being, and then now decide which one of the two is the largest. All right, so let me run that number real quick, and good, we do. I didn't run this math in my brain beforehand. So we get to now 8,125 VA for the AC system, and now it does put it over the heating system. Now, I'm not going that complicated into this question, right? I'm not giving you two HVAC systems and some different VAs here and then asking you what the total is, because again, you can see how hard just getting through a little bit of this can be, and we're just learning it. But this is how deep it could also go from there, right? Because of the motor, right? Well, I should say because of the compressor in the HVAC unit. Compressors are kind of like motors in that they have a very big energy startup. So because of that, it's technically a little bit of a bigger load. So we're just considering the first part of this that just says which one of the two is larger. That's the number I'll use. No derating at all. All right, no derating of any of this. Now, again, if we had multiple, if we're looking in a commercial building and we had multiple air conditioning units, then yes, as always, if it's potentially, sorry, I just got an email from a student. If potentially all 6 of the HVAC units on the rooftop of a building are not going to be on at the same time, and they're likely not all going to be on at the same time, then I don't have to take 100% of all of those ACs when I'm sizing the main breaker. So that leads us to this just being 7,000 for the AC. Now, for the garbage disposal, for the dishwasher, and for the water heater, since we, one, don't have more than 4, and if we had a 4th one, the garbage disposal excludes this 75% setup, or 0.75, then we just go straight, add everybody up, plus the 4,800 of the water heater, and now 5,900 VA is what you should have for, and I'll just put here apps. For appliances, not small appliances, appliances.
So that's garbage disposal to the water heater?
Yes, just add them up because the rule says, and I'll bring it, let me see where it'll be easy for you to distinguish it. Yeah, just right there. It comes from the article, this one actually is not on page 96, I don't think. Oh, it is, no. No, it's not. It's 2/2014. Yes, let me go back up. So it's a little bit closer to the front there. 2/2014 for this one. No, actually, I apologize. 2/2014 was for things like a spa and these other than loads, right? Pool pump. Well, that falls under a little bit more of a motor. Sorry, I do think it's actually on page. Let me just double check this one. Yeah, it is actually on that same page, 96, 53. Sorry about that, 53. There we go. Right? Here is that section here. So 2 things about that section. 1, it tells us the things that are not going to fall under this rule. The cooking equipment, the clothes dryer, heating and cooling systems, the EV for the car. The things that will fall under this are other appliances. So that's why the jacuzzi, yesterday when we were doing that example, Oh, by the way, that's the last thing I forgot to mention, that I posted that example that we did yesterday in class, if you wanted to work yourself back through that, right? Where we had the spa that we looked at, and for those of you who may have also missed it. All right, so that was this article here that says applying a demand factor of 75% to the nameplate rating, so whatever the VA is, of 4 or more appliances rated at either a quarter of a horsepower or, and I'm using this or because we're not doing horsepowers, 500 VA or greater. So the cutoff point is 500 VA. So 450 for this garbage disposal already excludes us from being able to apply the 75%. And the fact that I only put 3 of them and they have to be 4 or greater. Now, in the 4 or greater, if I had, let's say, 6 of them, and 2 of them were under 500, but the other 4 are over 500, then we apply the 75 to everybody. All right, hope that's clear. You total up all 6 of them, and then 75%. Even though 2 of them are under the 450, because we have 4 of them that are over, we still apply this rule. And that could simply, like I said, that could be a question that you'll see on the exam. If I have X amount of appliance loads, I have to think of 6 appliances. Okay, so let's total this up, see where we're at. And has anybody got that number? I can run the math.
34, 78. 34 is gonna be like 49.
I got 4103 if I run all these numbers together.
41003.
Yeah, we got that? So that is, anybody got a different number? Pause there. Again, the 28103 is what we brought over, so we already worked that out. It is in the video, so if you needed to get there. 7,000 was the air conditioner, and 5,900 was the appliances together, no 75% added. So I'm confident coming over here with this number. 4103. That's a good size situation. That's a good amount of VA to deal with. And again, we've reduced. It should be more than this. All right, so we divide by 240 for our Ohm's law approach to the amperage. All right, I didn't put total amps here. I guess I'm gonna put it here just to have it because that's how we get to the breaker, but let's at least have the number that we're working with. All right, and I got, 170.84 should be the number. Actually, let's put them in order. Here we go. All right, so I got 170.84. So like the code says, we'll just bump that up and make that 175 amps for our total amps. And then we go to Article 240.6. I'll put it over here. And does anyone have the breaker size?
It's 48.
Should be 175, no?
Yeah, 45.
What's that?
175.
Correct.
Yeah.
Very good. Yeah. That's what the number I was hearing. I just wanted to. I thought I heard a different one. Very good. Now, fun fact here is these are hard to find as a main breaker for a house, especially if you want to do like the meter combo with the panel below it, which is what everybody wants these days. So I was doing a house in Joshua Tree for a friend, but full-on job, contract, everything, but just a person I knew. Bought a property in Joshua Tree, had a little small house and a big mechanic shop behind, so turning both of these into Airbnbs. The small house, we calculated out, I did a full load calculation like this, and we found that 125, which is a very easy common one to find, not available. It had to be too small, so by the time I was done calculating, it was going to be 150 amp main, and I could not, he and I scouring the internet, could not find the meter combo, just to show you remind you what that is. It's the meter that measures the wattage in the house, comboed with the breakers as well. It also had to be outdoors. So the 150 that I calculated could not find it. All right, now it has a relationship to do with this. What we had to do, which one could I find? Well, I can't drop to 125, which was everywhere. 100 everywhere. 150 couldn't. 175 couldn't find it. Since I couldn't make it the smaller ones, I had to make it the bigger ones. The only other one we could find that's readily available was 200 amp. All right, a 200 amp service. So now you're got a question. Well, I totaled this all up. Let's use this. I totaled this all up to 171. My main breaker is supposed to be 175. Can I put a 200 amp main breaker?
Yes.
Absolutely. Very good. You can go higher. All right. Sorry, I mean, it's a little tiny. I think it was like 700 square feet maybe, and maybe I'm being generous. With a 200 amp service. With 3-aught coming down, I think it was 3-aught, 2-aught, I think was what I brought down. So keep that in mind. You can always go a little bit larger if things are not available. All right, if things are not available, you can go a little bit bigger. Wires have to match, and so as an extra here, and just because I'm making this in the video just to keep it in reference, what wire size would we make this?
One up?
We would go with the 1-aught, right? And from yesterday, I believe it was even the same number that we had. Yesterday we had 1-aught also. I mean, look, once you do this a lot, you're going to come to understanding. 1-aught, 2-aught, 3-aught, these are pretty standard for services going into a house. Number 1 is also for the 100 amp. So 31012A was the table, and that table takes us to an easy to use way to find the wires, because you can go into 31016 and go with the ampacity and start to navigate through the right. Got to make sure you're on the right column of 75 because it's a hover. But I'm just trying to get over the table, and here it was. It got there faster than I thought. This table here, 31012A, if you didn't see it yesterday, gives us that. It says 175 amp main breaker, then we use a copper 1-aught. 3-aught if you want to use aluminum, which you absolutely can. No problem. You can use that. Now, keeping in mind, since we did a little bit of that, and we're going to do a little bit of this maybe today, we'll probably jump into this section, but the temperature limitations on these conductor also applies. If it happens to be that this is going to face some heavy heat, then we go into 314 and start to apply the temperature correction factors. So we're never done with wires. We always got to consider everything else about the code book that might be, might be overriding something that we've already come down in calculation with. That's why going up is never a problem. Coming down is a problem. All right, just get back to 220. All right, so as you're staring at that, if anyone has any questions, a number that they're looking at that they don't have, or any follow-ups on the article, and we'll keep going and we'll wrap up this 220 section. And so I just get back over to it. All right, so I'm also going to backtrack just a little bit. Sorry, this was going back over here. This is the first one that we did. We came up with these answers, and this is the numbers that we have. So that's the one I mean that practice question is up, so that you can redo it if you want. Just make sure you have all the information. And these were the articles that you're also going to need, right? These are the supplementary articles. So the ground wire, the reason why I'm not asking it is it's going to be the same size. It's going to be a number 6, but the way we got to the ground wire is the same thing. There is a table that says based off of the size main breaker that you're using, and I want to emphasize on that, all right? Not this number, the size of the main breaker that you're using. That's the number you're going with. Then we size the ground as well to it.
So same thing in
Yeah, that's what.
All right, if we have any follow-ups, please feel free. Jump on in there.
Like 2 weeks ago. Yeah, I kind of remember it, so, okay. Good, it's much like, yeah. So you can.
All right, so let's keep on going. If there's any follow-up questions, but if we jump over to page after the table, page 98 is where we're going. I'll just remind everybody of the table that we had for the range. Now, we didn't go into column C. Column C is a little bit annoying because it takes us into the informational notes down here for larger than 8,500 VA ovens. Now these get really, really, really big as far as ovens go, and so divide that by, yeah, which is not unlikely that you'll see these ranges that could be a little bit bigger, but there's a whole calculating aspect to it. And again, if we were just doing this in this module, which 220 is one of these articles that you can just spend 3 weeks on, because you can do dwelling units, we can do multiple dwelling units, apartment buildings, commercial buildings, industrial buildings, we can do multiple ovens, and then really get down the rabbit hole of setting this up. Basically playing engineers, if you will, right? But you just want to understand the basics of it, which we're going to get to here in this part 4, optional feeder service loads. I just want to point out a few things that there are some other tables. Don't get confused when you're doing the exam or anything like that and come over to 256, which gives us for kitchen equipment 100% when it's 1 or 2 at 100. And this is kitchen equipment. This is not our appliances, our household electric ranges and such. All right, so don't get confused with that table. Now, a few other things that I wanted to point out, which is this section here is talking about sizing the neutral 220/61. The neutral is allowed to be smaller than the ungrounded conductors. All right, if we were sizing, for example, the neutral for the house that we were just doing, the neutral does not have to be the 1/0 conductors that we said. All right, the neutral does not have to be the 1/0 conductor. Now, there are building codes that supersede this almost everywhere that I've ever worked. So when it comes to residential, right, just residential, I've never been in a situation where we've undersized the neutral. Right, it's always been the same size. But in commercial and industrial building, this is something that gets applied a lot. All right, we apply a lot that little rule that, just to read it out here, the feeder or service neutral shall be the maximum unbalance of the loads determined by this article. The maximum unbalanced load shall be the maximum net calculated load between the neutral conductor and any one ungrounded conductor. There is an exception, but in this exception we have to increase a little bit, but let's not look at the exception. I just want to explain what that means. And there is another section down here that also covers the unbalanced load in excess of 200 amps, etc. The reason why the neutral does not have to be the same size as the HOTS is because the neutral is not used for all loads. Right? Not all loads use a neutral. I'll point some out that have no neutral at all. The water heater has no neutral at all, and the air conditioning system has no neutral at all.
How do you determine the unbalanced load?
Yes. How do you determine the unbalanced load? Well, 2 ways. One, you need to know this. Which ones are not using a neutral? Now, with experience, you know which ones are not using a neutral, but if, let's say you were a brand new engineer out of school, you've never stepped foot on a job site, you don't even know about wiring air conditioners specifically, you would look up the nameplate rating, the nameplate information of the devices that were going into the house, appliances and equipment, and then you would come up with that by looking at the specs and seeing, 2-wire, hot, 240 volt system, no neutral, and so then you would get that information from it. And so once you determine, right, once you determine what the non-coincident or what the unbalanced is, and again, how do you do that? Well, you do a versus. All right, in this case, how you would do it would be very simple. All right, you would come up with the VAs that you remove from here. All right, so I would remove 7,000, I would remove 4,800 for the water heater. Now, again, experience and the oven does have a neutral. The dryer does have a neutral, but the neutral is really, really, really dealing with almost very little, if nothing, of amperage. So I could exclude those also. All right, now just for an example, let's run these numbers just so you can see what I mean. So again, I'm going to subtract from 41. I'm just going to put 41,000. I'm going to ignore that 3. But I'm going to take out minus 4,500 minus 7,500 for the oven. Don't worry about the 6,000. Let's not do that conversion right now. I already put in these numbers. Minus 4,800 for the water heater. Minus 7,000 for the air conditioner. And what we're left with, let me slide over here. Okay, what we're left with now, I'm going to bring that number. This was our original for the ungrounded conductors.
You're using this.
But for my neutral, I'm removing that much. Sorry, this is the total that I'm removing, excuse me, from the 41,000. And that's going to be 200 here. All right, these are the loads. Again, these are the loads that do not use a neutral. All right, these are the loads that do not use a neutral. So 41,000 minus 7,200 equals 23,800. And this is what I size my neutral to, not that number. This number is for the 1-aughts for the hots. But my neutral can be a little bit smaller. Divide that by 240. It comes up to, divided by 240, 99 amps. That's annoying. Let's just call that 100 amps. So my neutral is sized to 100 amps now. And same thing, I go to 310, 310, 12, and I look up the size for 100. I think it's a number 1, let's say, for example. I'm not 100% sure on that, but. And now I have 2 hot conductors, 1-aught, coming into the panel, and 1 number 1 neutral coming into the panel. This is allowed. This is allowed. Like I said, dwelling units, they don't usually do this. They size everybody the same because of future work and expansions and stuff like that. People are, but in a commercial building or especially an industrial building, when all of your motors in the building, which is mostly what's in an industrial application, doesn't use a neutral. So definitely in those sections, you can reduce the neutral by. So I just want you to have that, because that question just on that level might come up. Right? The unbalanced load determined by this article. That's what the neutral can be smaller than the ungrounded conductors. All right, and so this is the article that we'll reference as far as unbalanced load. All right, determined by the unbalanced load. So we don't have to get into all the calculations. Just understand that the neutral can be a little bit smaller.
Is that neutral size smaller just for the panels, or is that for the regular conductors too?
That's just for the panels.
Okay.
That's just for the panels. So, because of that, all right, because that neutrals can be smaller by all of the numbers that we just said, there is actually a section in 250, right, in Article 250, which we'll get into in Code C, that gives us a minimum size neutral. It says, okay, I know you can reduce the neutral to the unbalanced load, and again, in an industrial building, that unbalanced load could be tiny compared to what the motors and the hot conductors have to deal with. But because I know you can go smaller, I'm going to stop you at a certain point. I'm going to say, yes, you can go smaller, but up to this number, all right? And that is going to be found in Article 250. and it's a table for the grounded conductor minimum size. And it's the same thing as for the 1-aught that we found here in Article 3.10.12, and the same thing for the 250.122 article that says, based off of the size of the main breaker that you have, this is the smallest size conductor that you can use. All right, any follow-ups on that? I think we got the... All right, now let's jump over here to the right where it says optional feeder and service load calculations. So there's an optional method, all right? There's an optional way to have gotten down to where we got to when we calculated a 1-aught, all right? There's a, now, some people even find this way to be easier, right? Some people even find this way to be easier, and I would argue that maybe, yes, it'll be easier, but reality is when it comes to the code exams, they're going to ask you a lot of questions to things that we just applied, like dryer loads, oven loads, or ranges loads. I got to remember calling the range. The EVs, the appliances, the small appliance, the laundry circuit. So since so many things come out of that, it is important to know how to do the other method, which helps you, again, establish all of these code sections that we have here, 55, 60, 53, and all the other ones that take us through all of this. So the optional method, all right, 250.82 says this section applies to houses only. So this is not just, it's an optional method, it's an optional method for houses only, not applied to commercial buildings. Having the total connected load served by single pole, right, single phase, 120, 240 volt, which is most houses, or 208, 120, set of three wire, meaning hot, neutral. All right, hot, neutral. That's a 3-wire service. So not a 3-phase system, again, dwelling units. I have not run into that situation where I've seen a Y transformer feeding a house, and instead of having 240 at the panel, the house has 208, which is possible. It's not possible. It's possible that you would have between A phase and B phase 208, but it comes off of a different type of transformers that are usually not in residential areas. Usually in residential area you have what we call a delta transformer, and that transformer is 120, 240. So everywhere except for Florida, because Florida has 110, 220, but it's the same application, it's going to be 120, 240. The other thing about this is, 1, it's for dwelling units, 2, 120, 240, and 3, it's only for 100 amps or greater. So if the house was a small house of 100 amps, you don't do this load calculation for it. Unfortunately, you have to do the load calculation to find out if the house is 100 amps or greater. And so it might be smaller, and so you might not, you run through all the numbers, you're like, oh, I can't use this method. Let me go back to the other one. But here's the way it goes. All right, here's the way it goes. The general calculated load shall be not less than, that's a really annoying way of saying, minimum size. Be not less than 100% of the first 10,000 VA plus 40% of the remainder of the following loads. Okay, so the following loads are 3 VA per square foot. Let's do an easy one. Let's say 2,000 square feet times 3 equals 6,000 VA for the foot squared. All right, just our normal general lighting load calculation. To this 6,000, you add the 1,500 small appliance loads. Minimum 2, so let's just use that number of 3,000 VA. All right, I'll pause here, make sure everyone who is writing this down has time to write it down, and also anyone looking at it going, wait a minute, where we at, can figure out where we're at. I hope we haven't lost anybody that much. So again, this is an alternative method. But notice so far, we're not doing 3,000 first and then 35% to those 6,000. That's usually what we do. We separate and then come up with a new number and then apply it to the small appliance and to the laundry circuit, which is the next one in there, right? Laundry and two small appliance branch circuits. So we'll include the 1,500 VA required for the laundry circuit. Additionally, what else can I throw in here? Well, number 3, the nameplate of all of the following. All appliances that are fastened in place, permanently connected, or located to be on a specific circuit, like a refrigerator, which we haven't thrown into our thing. We've forgotten refrigerator. Right? A refrigerator is the reason I bring it up. It's not fastened in place. You can move a refrigerator, of course, so it falls under located to be a specific circuit. Bless you. The refrigerator is going to be its own circuit. So also the refrigerator. The oven. I can throw the oven in here. I can throw the dryer in here. I can throw the water here. So literally everything that we listed, let me go back over here. Everything that we listed after this point, the dryer, the oven, not the EV load. I will come up to that. The garbage disposal, the 650, the water heater. All of those, going back over here, plus, continue, right? Number 4, continue. Let me go over to the code book, just because I'm losing space down there and it could be annoying to read that. Plus the nameplate amps or kVA, either one, because usually we get one or the other, of all permanently connected motors not included, right, not included in 22082B. All right, and 22082B down here gives us some air conditioning systems, so not including the air conditioning system. All right, so coming back over to the general. So the only one that is not part of this alternative method is the HVAC system, because they are always on. All right, it's one of these, like the dryer's not always on all day. Nothing is always on all day except the air conditioner. So we can throw in all of those other loads, right? We can throw in the garbage disposal. We can throw in the water heater. We can throw in the dryer 5,000. It does not mention EV either, so we don't, it's not a fastened in place appliance. Well, actually, sorry about that. It does fall under located to be on a specific circuit, so we can throw in our EV. That one's questionable. I would argue that one with an inspector. See, these are places you can argue with inspectors where is or isn't it. I can establish that. It is located to be on a specific circuit. It isn't an appliance, so there is an argument to be made there. In fact, I'm going to remove it because questionable. Let's not go 100 on it. So we got our dryer. I don't have to keep throwing all the other ones in. And then what I'm trying to get to is our last and final point here, which is we just simply add all of this up and we come back to this. All right, we add all of this up, which, let me run it through the calculator just to have a number here, unless somebody has it. Right? No one did.
20,750.
Sorry, say it one more time.
20,750.
750. Great. Right, and now to that, we add our air conditioning load. Let's just use the number we had a little bit ago, 7,000. Oh, sorry. Oops, sorry. We apply the 10 kVA separation to this one. We go 10,000 over here. Then the remaining 10,750 gets the 40%. All right, so we can run these numbers. Let me go ahead and run these numbers just for having them. Plus the 10,000. So we reduce that 20,750 gets reduced to 14,300 VA. And then, like I said, to this we add the air conditioning system, and I would argue again, we would add our EV system to this, and now let's say 14,300 plus what's that? 14,200 with those two, and now we have a total of 28,500 VA. Now keep in mind, I excluded a bunch of these folks over here. We have a different square footage that we're working with. We have less small appliances than before.
Oh, that's AC and EV.
Yeah, this is air conditioning system up here and the EV system there as well. So all of that is a way, I'm just gonna remove this, right, is a way of doing the alternative method to the one we just did. All right, now some people like this approach, right? Some people like the approach. All right, in the, actually I did have it here, the HVAC system is 100%, so there's no changes to the HVAC system. And then it's the same situation, whichever one is bigger of these two. All right, and still we just do 100% of it. So this is an alternative method to it. So what I want you to know about the alternative method, just so that we know what we're highlighting and just to pick up, and just a few things that we were talking about. Alternative methods is just for dwelling units. It's for these here, but what is that telling me for single phase systems only? Not three-phase systems, where we do have that 12208. All right, it's for 100 amps or greater. Sorry, there's a line through it. Let me erase that line. All right, for 100 amps or greater. And the 10,000 kVA plus the 40% rule falls under everything down there below. All right, the small appliance, the laundry branch circuit, including all of these. We can ignore 4 because I'm not going to bring in any motors. We haven't brought any motors yet, just because we have a whole motors module. Okay, so now the rest of this, right? The rest of this article, because this article goes for a minute. It's a big article. Like I said earlier, it even gets into farming loads, buildings that are farms, right? It can get, because they have a lot of different equipment. We can have marinas and boat yards. So this article goes. And not to say that a journeyman exam won't ask you about marinas, floating buildings, and docking facilities. It's not going to be the bulk of the questions that you're going to be getting, all right? This is why we focus on the early stuff. Because the bulk of the questions you're going to be getting are about dwelling units in most cases. All right, a couple things sprinkled here and there. All right, like for example, we can do the total VA per square foot, and it's not to say that I won't ask this question. All right, that I won't ask this, I'm just trying to get back over to the section. Remember this as well. All right, we're not reviewing, so we'll do more of this when we review, but I could say, what are the total VA for general lighting of a hospital? And so you come over to the hospital, you find the VA per square foot, and if I give you the square foot of a hospital, you should be able to give me the VA per square foot of anything that I ask. All right, and here's the thing to remember is in most cases, other than for the ones up here, warehouses being one of them, it's 100% of whatever VA. You don't reduce anything. All right, you don't do a first 3,000 and the remaining 3,000. So whatever VA I say, hey, how many total VA general lighting for an exercise center? Okay, come over to the exercise center. How many square feet? 10,000 square feet. All right, it's 1.4 VA per square foot, and come up with a calculation. Whatever that number ends up being, let's say for example an exercise center, it's 100%. There's no reducing. There's no demand factor. So you can ignore. Right, same thing again for those of you who might not have picked this up. We did some track lighting stuff. So there might be a question on what are the total VAs for track lighting, and it's based off of the length of the track lighting. All right, because we're going to walk away from this article now. I just want to make sure that we are good with everything that we've said so far. If anyone has any extra questions, here's where forever hold your peace. All right, now, good thing. Well, go ahead. Questions?
Backtrack a little bit. How did you get 20,750?
It's 8.
No, when you did it. And when you took it to the, I think it should be
Where at with this one?
the way you just did before. And then you took the 10,000 and 10,750 multiplied by 0.40.
Oh, I added everything up that I had posted here on the side.
When you split the 6,000, and when you take the 3,000 from the 6, you don't include the 6, right?
Well, in the alternative method, you don't take away the 3,000 from the 6. In the original one, yes. In this method over here, yes. This one we do take away after we come up with the, sorry about that, the square footage times 3 VA. Then yes, in this method we do start to take away the first 3,000. But not for that alternative method that we just did. The alternative method, and this is why some people like it, is just literally add everything up from general lighting, small appliance, laundry circuits, all the other appliances, the oven, the clothes dryer, water heater, etc. Just add everything up, get that total, and then first 10,000, 100%, the remaining at 40. Come up with that number, throw in the air conditioner, throw in the EV, throw in anything else that, because, you know, let's say those questions. The spa is not covered here. Jacuzzis aren't covered. Water pump for, you know, the pool is not covered. There's a lot of things that aren't covered here. So I think I ran all the numbers correctly. If I happen to have a number off or anything like that, it was just my bad math. But I was using my calculator, not my brain, which fails me sometimes. So hopefully I had the right numbers. But the idea is, again, just to kind of give a quick there. Once we come up with our 3 VA per square foot, we've come up with our general lighting. Then we add the small appliances, the laundry, garbage disposal, water heater, add everything up. Just keep putting in the range, whatever is going to be in the house. Come up with that total, and then 10,000 puts aside, remaining at 40%, and then bring back to the 10,000. And that's where I got to all the numbers that we had here earlier. All right, good. Any other follow-ups to that? Unless that did not answer the question, you have a follow-up as well. All right, so again, if anybody wants to do the practice guide, practice calculation for the, and you'll notice it says the standard. It says standard method. That's the other thing about this method is this is the standard one used. All right, it's the standard method used. It has all of the articles there that come along with it. All right, it has a little 500 here. Everything is here posted for you guys. You can follow. And it also has the, we didn't get to this. I don't want to get too far into Article 250. There is a grounding electrode conductor that we could even do. You'll know what size wire we need for the ground rod. There's a lot that still can be followed up. But it has the divided by 240, the overcurrent protection device main breaker table, the 31012 for the service feeders. All right, if everybody's satisfied, and we'll do a little bit more next Wednesday when we review. All right, let's jump into our next article. And it's another big article. Not big in the sense of it's got a lot of details, so we'll be going through all of them. So we're jumping over to Article 310, just trying to find a page for you, and this will be on page 177, Article 310. Page 177. in the section to it, but I'll do it now. Page 170. And this article is like some of the articles in the back for the condo. It's just got a lot of tables. There's a lot of tables in it. And all these tables walk us through all kinds of things. All right, some of this you might even already know a little bit. You probably picked up from Code A. 'Cause I know you visit this in Code A. So, all right, if you're there on page 177, let's jump in. So this article is about the wires, not just about the wires, but wiring, ing, general wiring as well. How to install wires, what wires to use in specific areas. This is going to set minimum sizes for stuff, etc. So now, interesting, they include up to 2,000 volts, which usually we end at 1,000, but this article covers the general requirements for wires, conductors rated up to and including 2,000 volts and their type designations, insulation types. This is where a lot of information comes in with all the different insulation types. Now remember, column 60, degree, 75, and 80, all of those insulations, they mean something. All right, there's designators for all of the THHNs and etceteras, markings, mechanical strength, etc. Now, first note that we want to stop at and unpack a little bit, which is, what is the smallest wire we can use? And it didn't say a specific place. It just says minimum size of conductors.
14.
14, very good. All right. The smallest wire we can use, except as permitted elsewhere in this code book, and this is going to be things for low voltage wiring, control wiring, things that do not carry amperage. So that's just a little side note that I'm going to put here. This would be for I'm going to put low current, not zero, low current circuits. All right, if you want to add that or just make a note. But that's where elsewhere that is permitted is going to allow for the use of 18 and 16 gauge low current circuits. The only side exception to that is extension cords or cords on appliances, but I'm not going to apply that one there. Actually, we could also give this the second, which is appliance cords or just cords. All right, keep in mind that too. All right, not an extension cord that I'm going to throw on the floor. Those are not covered by the code book. The code book, that would be UL that is covering stuff like that, how to build extension cords. These are cords to appliances or fixed in place appliances. They're going to be going into our outlets, not extension cords. So in extension cords, or not, rather, yeah, I said it, in cords on appliances, washing machines, things like that, you can see 16 and 18 gauge in some specifics. All right, it is permitted. All right, so that's the first thing. The second thing, and now I'm going to jump over to the code book now. All right, so make sure we have that one. And as always, two things, and most of the time I'm asking about copper, but if we happen to ask this question in aluminum, what is the smallest or minimum size aluminum conductor we can use? It's 12, right? It's always going to be one bigger for aluminum because it holds a little bit less amperage than its same size copper counterpart. All right, now the other section to this B says conductors in this article shall be of copper, aluminum, or copper clad. Remember, copper clad is simply aluminum with a coating of copper, right? It's mostly aluminum, but it has a coating of copper on it. That's why it gets kind of dumped into the aluminum side when we're looking at the conductors. There we go. Okay, now the other thing to highlight, all right, the other thing to highlight is C. All right, there's a couple of things here that I'm gonna not go over. All right, this is more on aluminum. I don't care too much about aluminum. All right, let's get down to stranded conductors that are installed in raceways. And that's another thing. These are the wire, when we're talking on this article 310, we're talking about the wires that we're pulling into conduits. Whether they're flexible conduits or not, like, you know, of course, MC cable, which you're using, is sprinkled in here. Romex is sort of has to fall under these rules as well. But because this is more about installation requirements to things, wiring methods, and these are about the wires that we're pulling. That's why it says it this way. Where installed in raceways, where electricians are pulling it into conduit. Conductors 8 or larger shall be stranded. All right, shall be stranded. Unless specifically permitted or required in other areas to be solid. And this would only be for our grounding conductor, the ING, the green one. All right, the green one can be, and by the way, only one size larger. It's an odd thing about this code is that they cut off this stranded conductor at number 8, right? They cut it off at number 8, but there's only one other wire that is even made solid. All right, that's even made solid. And that's going to be the number 6, because the next size higher, which is the number 4, is not even made in that size. All right, I'm actually trying to find, because I know I have the table here. Yep, there it is. And I was just going to remind you of that. All right, oops, wrong table here. Sorry about that. Not the table for the boxes. Where is the table? No, I thought I had the table. I guess I don't have the table. Sorry about that. I guess I don't have the table. It's page 700, excuse me, and 70 and 25 of the code book, which gives us the sizes and circular mills of the conductors. And then, oh wait, yeah, I know where that table is. Remind you of the table. Here we go. Sorry about that. Sorry, here we go. I forget all the classes that I'm teaching. I forget where I'm at and who I taught what to. So number 8, right? That's the where installed in a raceway, number 8 or larger shall be stranded. And like I said, it's the last wire that they make solid. So there is no option when it comes to number 6, number 4, or number 3 to buy a solid conductor. So all it's saying there is, right? Can I put a number 8 solid in a conduit? No, unless it's the grounding conductor. All right? No, unless it's the grounding conductor. All right, but that is the last point of solid anyway. So they cut it off exactly where solid ends. All right, coming back over to that code section. So far so good. Let's just make sure stranded conductor 8 or larger if it's in a raceway. If it's in a raceway. Now again, what conduits aren't in a raceway? You're right. All conduits are very likely in a raceway when they're, especially when they're the ungrounded and grounded conductor. They absolutely go in a raceway. The only one this allows to be 1 outside of a raceway and 2 solid is the grounding conductor, the ING, the green one, which this next section is about that conductor, right? It sends us even into Article 250, which is the grounding article. Conductors not specifically permitted elsewhere in this code. Again, the grounding conductors is the only one to be covered or bare shall be insulated. So what that is saying is, all right, let's just run through all the numbers so far. Smallest wire, 14 copper. It has to be copper or aluminum clad. If it's number 8 or larger, it has to be stranded when it goes into a conduit. And all wires going into a conduit shall be insulated unless it's allowed elsewhere, and that's going to be the ING, the grounding conductor. And this note down here, I'll let Mr. Williams next module walk you through it. This is about in some situations, very high voltage systems, you can run a solid neutral, but I don't want to get too far down the rabbit hole here. All right, we're not going to get into this section. All right, You guys covered this section in some ways in Article, I want to say 110, no, maybe Article 300, sorry, Article 300 when you were in Code A. All right, and this is about how deep do these things have to be when they are covered up or buried, and it depends on the conduit or if we're burying wires directly. All right, column 1, column 2, column 3, column 4 are all going to be specifics, right, the EMT and so on. So I'm going to jump down to the second part, the way these things are built. Right, construction specifications of 310 or for conductors. All right, so if you are there, I'm going to skip this for 1 second. We're going to come back to this because this takes us to starts us here in the table of all the insulation. So I'm going to wait a second to get there. All right, let's just highlight a few extra things and then we'll jump into that table. So first things first is, again, identification. Just keep reminding you of this. It's one of those that is in a lot of different code sections for the branch circuits, for the feeder conductors, etc. And that is the way we identify our wires. All right, this is probably now something that you have memorized even. All right, the grounded, the neutral, white, gray, or white or gray. It can have different stripes on it, but let's ignore that particular wire. The grounding, ING conductor, green or bare copper are the two ways that it shows up in most cases. The ungrounded conductor, anything other than white, gray, or green, except we do have a system. All right, for wiring, we absolutely do have a system. I have given this in the past, but I'm gonna simply remind us of it. 240. The color coordinating system is black, red, and blue if it happens to be three-phase. This is the one that takes the white neutral. All right, we cannot use anything else, even though, again, the code book says any color other than white, gray, or green. Yes, but building codes have established, and you have to memorize these. These are memorized now. All right, as we keep going through the modules, memorize these numbers and the color. This one is easy to remember. It acronym is BOY: brown, orange, and yellow. This one is not a white neutral. You cannot, even though it says white or gray. It doesn't tell me when white or gray. It just says white or gray. But in the 480 is the only time the neutral is gray. All right, that now has to get fused in there. If you get asked this question in the field when you're hired, you gotta know these answers. All right, so just pointing it out again. All right, now the next part here is going to be just the markings on the wire, and so all of the wires that we use have to have some kind of information on the conductor. Kind of the marking stuff is a little bit out of, the manufacturers are responsible for marking on it. Inspectors just want to make sure that we're buying stuff that's, that's correct, that's UL listed, that's, that we're using the things that are made to fit the standards, right? A lot of this stuff, how do I enforce the wire having maximum rated voltage on it? Right? This is all manufacturer trades. How do I tell the wire to have I don't make wire. So when I buy wire, I have to make sure that I'm buying the legal required wires with all the UL listings, not ordering something off of Amazon or so. This is why they're trying to get through a lot of these. But all of these markings and such, this will just be part of the wire. So let's jump over to the table. All right, let's jump over to the table 310.41, conductor applications and the insulations. All right, and the insulations. Now, this is one of those where you guys can just be here at this first one, all right? I'm gonna start to scroll through it. All right, I'm gonna start to scroll through it. And this is the first part of this, right? This is the first stuff that we're having here. It's gonna keep going. It's gonna keep going. There's our very common wire that we're using these days, along with, this is all one insulation for one wire. Keeps on, right? This goes. All right, there's a lot of insulation types. It is not possible for you to memorize these, so this is one of those where we simply reference the code. And when do we reference the code? Well, to be honest, when you get asked a question about it. All right, that's the honest thing about these insulations that I'm about to walk you through. There is going to be one that I want you to simply memorize because it's the one that we're using now. As far as everywhere that we pull wire, this is the wire that we use. There's going to be one of those that, like these, fuse these into your brain as to what it means. It'll be the THHN, THWN, but. So how can the questions come at me, right? How do these questions come at me? Well, because it's a table and because it has a lot of features to the table, I could simply ask a question about an insulation and where can we use it. All right, so the main things I want you to know about here is one, how to find the insulation. It'll be in type letter. So if I ask about FEP insulation, or I'm just going to scroll down for scroll down fun, all right? RHH insulation. What is the material, all right, or the trade name, sorry, the trade name, I didn't mean material here. The trade name is FEP, or fluorinated ethylene, etc. These words are tough sometimes. This one is easy, thermoset. Okay, got it. The other thing is RHH, trade name, insulation type, all right, temperature rating. Know the temperature rating of the insulation type. There's a question. What is the temperature rating for RHH? RHW. Where can you use RHH or RHW? Scrolling up here, just because I don't have it all on one page. Applications provisions. Where can I use them? Here. This is, if you wanted to write in your code book, where? Right? This is where do I use them? You use them in, depending on the insulation type. Mostly it's going to be a lot about dry and damp locations. Right? Dry and damp, dry and wet, dry and damp. So there's an easy one, right? As far as I want to be a teacher and set up a question. RHH can be used in dry and wet locations. No, right? Only dry and damp. So know the difference between damp and know when it says wet and which one is which. Insulation types different between those two. And then maybe this question comes up as well, where what size conductors can I use? Like, for example, PFAH over here comes in, true false, right? Comes in 400 kc mil. Well, no, if you come over to the size wires that they make for it, there is no 400 kc mil. All right, so let me go back up here. So this is the things that you just need to focus on when you get a question from here. What is the trade size? What are the abbreviated letters? What temperature does it fall into? Category does it fall into? Where can I use this wire? Dry locations, wet locations, damp locations, for machine, tool wiring. And then the size of the wires that it comes in. All right, the size of the wires that it comes in. Now, there's very common conductors, but the most common conductor that I want you to know about and what it means is the THHN. All right, the THHN, THHW, anywhere that you see a conductor that has TH, and not to say that we use all of these THs, we don't. We actually use one wire, and that one wire is THWN/THHN. It is both of them. One conductor, again, this is one wire with two types of insulations on it. Why do they do that? Because of, if you look at THHN, dry and damp location. So if I only had this wire, I could not use this in a wet location. But because the conductor is both insulations, then THWN is the wet location. So that's why they've made one wire with two types of insulations. Both of them are in the 90°C column. And what I want you to know about TH, anywhere they're using it, is thermoplastic. All right, I'm gonna write this on the whiteboard here in a second. All right, I'm writing it as we go, but I want you to highlight it. TH is thermoplastic. The other H, all right, the other H is heat resistance. All right, the other H is heat resistance. And if we look at the THWN, it has moisture. All right, so anywhere that you see the N, moisture. All right, so I have it here just consolidated, and we'll wrap up here. There's more to talk about now as we're simply starting to get into this, right, into this code section. So here is it consolidated. So that's why I say our wire THHN, and then the THHN2. Oh, sorry, I meant to put the 2 here. Is wet slash THWN. Oh, sorry, not the 2. What am I? The W. Sorry, WN2. Sorry about that. And like I said, this is one wire, standard wire that we use these days. All right, let me pause the lecture right there.